With Dr. Ken Rubin, sitting off the Palmyra Atoll using ROV SuBastian, collecting some more samples, a lot more samples today. Ken, real quick, this is a continuation of yesterday's dive, correct?
Yep. So since we had never been here before, this was a completely new site. I set up a longish dive that was a series of what we call transects. That's just a fancy way of saying make a repeat line across a set of terrain. And so in this case, we're on the western edge of the platform and upslope is to our east. So we've done a series of lines starting at about 200 meters water depth and coming up to about 100. And yesterday we had to pull the dive halfway through because of an ROV control issue. And so rather than pick an entirely new dive, we'd only made a couple of these passes, these so-called transects. And I really wanted to see the entire structure of this environment by passing over it 4 or 5 times. So we're essentially just continuing yesterday's dive, and it's been really important for us because each time we make a vertical transect and we come up to the shallowest part of this ancient reef, we see something different. So sometimes you see the same thing on each pass, and it gives you an idea of the environment where the reef formed was really continuous over this broad swath. And for us, a broad swath means an area of seabed about 1 mile long. But we're seeing different things each time we come up from deep into the shallows, and so it's even more important that we continue doing this all day, collecting samples, making video observations, photographic documentation, etc. So that's what we're up to.
And yesterday when we dove, we didn't do any mapping previous to the dive, but last night we actually got to use the shipboard mounted multi-beam to get some high resolution mapping, so we have a bit better understanding of what we're cruising along today, right?
Yeah, so one thing is useful to remember for anyone who takes a submersible, whether it's remotely operated or it's got humans in it, down to the seabed, we'd like to have some idea of what the seabed looks like, what features are down there, especially when you have an ROV with a tether back to the ship. We're always concerned with what we call entanglement hazards. We're also concerned that there aren't any narrow crags or overhangs that the vehicle can get stuck under. And so we always want to have some kind of multi-beam or sonar map of the seabed. And we have sonar data available from this site. It comes from a survey collected by NOAA about a decade ago. It's good data. It was sufficient for yesterday's dive, but not great data. And because this site is very close to a shallow reef, the captain of the Falkor was concerned that he wanted to be able to do the multi-beam mapping during daylight, where he could basically keep a watch out from the bridge to make sure that we didn't get the ship grounded on any shallow reef material. So we arrived at this site initially 2 days ago at night and decided to put the vehicle in the water without doing some mapping. But after we dove yesterday, we did some mapping here, so we have a higher resolution bathymetric map. It shows some more details than we had in our pre-existing data, and that's been useful for guiding the dive today. Nothing gigantically different. Sometimes we see very different features when we have a higher resolution map. But anyway, the Falkor's mapping system, its sonar mapping system, is excellent. It's very quiet, so oftentimes the data needs a lot of processing. We were able to run those lines at about 4 a.m., have the data up on the ship, and transfer it into a format that we can use in the ROV control room in about 2 hours. So it's a pretty fast turnaround. It's a nice system, and I'm very glad that we have it.
Yeah, speaking with the crew yesterday, they were commenting on how quiet the ship is. It's actually noted as one of the quietest ships for multi-beam mapping. So we're fortunate to have that. We do have a few questions that have come through on Facebook, and we'll be getting to those. I know Jackie and Sean have both posted questions. We'll be getting to those here shortly. what is it that we're seeing? Is there anything that we're seeing that's different here, what we're seeing right now today on today's dive, even though we're really only about half of a mile from where we dove yesterday?
Yeah, the stuff that we observed at depth has been pretty similar each time we've moved up through what we call the section of rock, of ancient reef rock, until we get relatively shallow. There's a platform at about 110 meters water depth. That's, you know, almost 350 feet. And yesterday when we were diving on that platform, we had lots of small cobble-sized rocks. These are things that look like, see the same thing at that depth today, but we're a little bit further south than we were yesterday where we were diving, and at that depth we don't have that. We have a flat platform with large slabby deposits. You know, it's difficult to tell from the pieces that we've taken what kind of coral was in there. We won't know that until the rocks get back to the ship and we cut them open. One of the important things for people to realize is that, you know, after a coral reef is drowned by rising sea level, all life doesn't stop. Other organisms take over, and so there's various kinds of organisms. You're looking at some of them right now in the view, things like you know, corals and sponges that grow on up from the seabed, but there are also other organisms that we call encrusting organisms that grow basically on top of the seabed, and they mantle a lot of the pre-existing coral structure that was there, and so we get these bits of seabed that look relatively flat, and that's because these what we call coralline algae, which when they're growing they can have some leafy parts, but they also have a bony structure that encrusts the seabed, and so it gives it a very different look, and we have to, you know, bring those pieces up and cut into them to see the coral that was present inside.
And when you mentioned taking a look to see what these samples actually hold, you were pretty excited yesterday with how many samples we got back that were showing coral deposits inside.
Yeah, definitely. So when we first started working at Penguin Bank about a decade ago, I was telling people that I would consider a dive to be lucky in a dive if we were batting 500, meaning one in every two pieces that we picked up had coral in it. And yesterday was our first dive at this site, and of the 19 samples that we took, 14 of them are coral. So that's pretty good. The other thing that kind of blew my mind a little bit is that I didn't see a single genus that is common in Hawaii in the corals here. So the coral skeletons are really different morphologically, and I think that's contributing to some of the different look of the seabed as we're driving the ROV through here. And so part of this exercise when you come to a new place is training the scientists, including myself, what it is that we're seeing, and convincing ourselves that we understand the what the reef deposit is telling us. Sometimes things are organized only vertically with respect to changing sea level. Sometimes things change laterally, and those usually reflect changes in conditions, like you're at a headland or an embayment, and different sorts of corals will grow in those different conditions depending on things like how clear the water is, how big the waves are, etc. And so I was, you know, quite surprised yesterday to see several genera of corals that I'm not familiar with. So I'm going to have to get out the atlas that we brought with, look at what lives here, and look at some structural diagrams to be able to make an identification. We don't have to do that here. That can always happen at the beach, but I'm always, you know, really interested in seeing new types of coral, and we're definitely, you know, getting that here. So just, you know, so people understand, if they haven't looked up where Palmyra is, it's 5 degrees north of the equator, so it's really close to the equator. Hawaii, it's about 20 or 21 degrees north, so it's in what we call a different biogeographic province. The water's a lot warmer here by the equator, and so especially in the central and eastern Pacific, we see different kinds of corals growing in that environment. When you get to the western Pacific, this is where you have the highest diversity, greatest number of genera on the coral reefs. Hawaii tends to have relatively limited variation, fewer numbers of genera represented. Something like 90% of the corals that we find on Hawaiian reefs are of three genera. And yeah, coming to a new place and seeing you know, really a different biogeographical province is also interesting for me. It's a bit of a challenge to learn all the names and looks of the, you know, how they look of the corals that we find here.
And we're not just going to be here, hopefully, at Palmyra Atoll. We were yesterday. We did steam over to Kingman Reef, and we did some mapping there during the daytime. And that's a fair bit different from a visual perspective as well, because here, sitting at Palmyra, when you look out, there's trees on the island. There's a number of different small islands that make up Palmyra, and at Kingman, it's really just a meter-wide sand strip that barely sticks out on the horizon.
Yeah, for now, this is the ultimate location that's vulnerable to sea level rise. Give it another meter and it'll be gone forever. Yeah, so you know, Kingman and Palmyra are part of an island chain. It's a bit like the Hawaiian chain, but in a relative sense, we're much further along the chain. The volcanoes get older and colder, and they start to sink underwater. They're extinct volcanoes, and they get fringed by coral atoll. And so where we are here at Kingman and Palmyra is roughly equivalent to going to Midway Island or so along the Hawaiian chain. And so Kingman Reef is, it sits atop, you know, a pretty tall volcano. It's probably about, it's extinct, of course, but it's about 4,500 meters high, and it's flat topped and it's sort of triangular shaped, and that just has to do with the shape of the reef that grew there. It's got a central lagoon and sort of an annular, triangular shaped reef that is only barely poking out of sea level a little bit, you know, up to about a meter in a couple places. And so if, you know, Palmyra is sort of treacherous for the ship, Kingman is really treacherous for the ship. And so, you know, the captain wanted to do the sonar mapping in daylight, and since we had to pull the ROV out of the water early yesterday for a technical issue, I made the decision to take the ship up there immediately so that we could do some of the sonar mapping to be prepared for diving. And you know, the reason I picked the two sites, it's you know, we have up to 5 days we can work here, and I didn't, you know, anticipate that, you know, exactly what we would find. So, you know, it's always good to have options. And if we feel like, you know, we've covered this site in sufficient detail after today's dive, we will probably go up and dive at Kingman tomorrow to see how different it is or it isn't. You know, we have to pick our sites based on the conditions in the ocean. The ship has to be positioned a certain way relative to the ROV, and when you have an island in the way, you know, certain sides of the island or the reef are places that we can't get to that day. So currently the wind and the currents are coming from the south and the east, which means that we're working on the west sides of the island. So there's a western exposure at Kingman that the slopes look very similar on the seabed to this site that we're at today, so maybe we'll see sort of similar stuff. There's also a northern site at Kingman that could be really interesting. It could be different. You know, by analogy, if you look at the coral reefs that you see in the Hawaiian Islands, our northern-facing reefs on the north-facing shores are really different than the south-facing shores, and that's because there's a very different kind of wave regime. The North Shore facing beaches get very large waves in the winter, so we call that a high energy environment. So the coral reef structures that grow there, they tend to be sort of beefier and stockier corals, and the stuff that you find on the South Shores, where we tend to have we still get, you know, waves mostly in the summertime, but they tend to be a lot smaller, and so you find different kinds of corals, ones there that are a little bit more delicate.
And when you speak about the currents and whatnot, that certainly plays an impact on maneuvering the ROV and the safety of the ROV, as well as getting samples. You know, just from watching the stream this morning, it's pretty obvious that there's still some strong currents going on down there, which has made sampling a little more delicate today.
Yeah, definitely. The ROV pilots are doing a stellar job. You know, even though it looks like the vehicle is sitting in place on the bottom, it really isn't. The vehicle is maneuvered by a series of thrusters, which are basically underwater propellers. And to keep the vehicle in place in strong currents, they basically have to keep the thrusters on and sort of drive into the seabed. And that keeps the vehicle sitting relatively stationary. Well, since we're working in pretty shallow water, which means the water is also warm because we're in the tropics, that combined with having to thrust into the seabed in pretty high velocity because of the high currents means that the vehicle tends to overheat when we're up in really shallow water. So every time we get up to the shallow water and then come back down at depth, part of what we're doing there is cooling the vehicle. And so I've actually sort of discussed a strategy with my colleague Terry, who is currently leading the dive in the control room, that when we get up into the shallow environment, we will try to take a sample, at either 100 meters depth or 110 meters depth. Both of them are of interest to us, but not try to take one at both on a single pass, because usually by the time we get to the second sample collection, the vehicle is too hot to do it. And so there's a lot of stuff that happens in the background that viewers may not be aware of when they're watching the video feed. But a couple things. Every once in a while an alarm comes off and someone needs to reset something or turn something off. We had to turn a camera off earlier today that had a ground fault. There's also a person who's controlling the manipulators and doing the sampling. So there's several different people working together as a team, and especially in conditions like this where the currents are kind of strong, and as scientists we have a specific kind of sample we want. We don't just say, oh, get me something from around here. We have a little pointer and we point at the screen and say, I would like a piece of that particular rock. And then they're the ones that have to figure out, looking back in time.
We're down on the stream, so we'll just give it a second.
Okay. When did it go down?
Just as you were starting to answer the question.
Oh, okay.
So.